Hey everyone, you're tuned into Edu-Malanga. On this channel, we create free tutorial videos for the Matric Mathematics syllabus of South Africa. Today we're doing the last lesson under the third unit of the year. The third unit of the year is exponential and logarithmic functions, and we're going to look at logarithmic functions. Let's start by looking at the basic form of a logarithmic function. Then we're going to do an example to introduce ourselves to the lesson. A log function has the form y is equal to log base a, so there must be a base of x. So what are the important features to point out in this example? You have y, which is your range, your output values, and then you have the x values, which are your domain values. These are your input values. If you don't understand the range and the domain of a function, there's a link in the top right corner to a video on our channel where we introduce these. And the last thing to note is the base again of your log function. So these are all the things to note about a log function. Let's generate our own log function that we will then graph on the Cartesian axis, and we'll look at some of the important features once we can see the log function. So the log function that we're going to draw is y is equal to log base 2 of x. And what we're going to do, we're going to put our domain values over here. So these are going to be the x values, and we'll write our y values over here. And once we've calculated all of these, we're going to graph the function on this Cartesian axis. So the values of the domain that we're going to use look like this. We'll start with 0.1, go to 0.2, do 0.25, then we'll do 0.5, 0.75, we'll do 1, 2, 3, 4, and 5. And so these are going to be our domain values. Now we're going to determine the values of the range, and how we do this is by substituting these values into the equation. So let me, for example, do the first one. When x is 0.1, your y will be y is equal to log base 2 of 0.1. Put this into your calculator and you'll find that the answer is minus 3.32. And we're going to do the same for the rest of these values over here. So I suggest you pause the video and take the opportunity to do it yourself. I've already done this beforehand, so I'm going to just fill in the values. So these are the values that we will plot on our Cartesian axis. So let's get started. We're going to start with this value over here. So when x is 1, y is equal to 0. Let's plot that over here. When x is y, y is equal to 0. So the point is right here. And let's move to the left. You have 0.75 corresponding to minus 0.42. And when x is 0.5, your y is negative 1. So let's start with the 0.5. When x is 0.5, your y is equal to 1. So it's about halfway there. And when x is 0.75, your y is minus 0.42. So over here, 0.75, I'm just going to estimate, and 0.42. So somewhere about there, I'm just making an estimate. The next value we will draw is when your x is 0.25, your y is negative 2. Okay, so 0.25, it's smaller over there. Your y is negative 2. We're moving to this values, yes. And when it's 0.2, you have minus 2.32. Okay, for 0.2, you have minus 2.32. So somewhere over there, getting smaller. And the last value would be 0.1 going to minus 3.32. So x is 0.1, even smaller, and minus 3.32, so somewhere over there. And that's this side of the graph. Let's move now to draw the other side. When x is 2, y is equal to 1, and when x is 3, y is equal to 1.58. Let's draw that. When x is 2, y is equal to 1, and when x is 3, y is equal to 1.58, so somewhere slightly larger than halfway over there. When x is 4, y is equal to 2, and when x is 5, y is equal to 2.32. Let's draw that. When x is 4, y is equal to 2, and when x is 5, y is equal to 2.32, somewhere about there. So let's draw this graph now. The graph of log base 2 of x looks like this. Here it's getting closer and closer to the y-axis, but not quite getting there. And let's write down that this function is y is equal to log base 2 of x. So looking at this function, let's write down some important features of it that just stand out. The first thing that we should note are our domain and our range values. So let's look at the domain again. If you recall, when we introduced logs, there was an important restriction that we mentioned, and this restriction was that a and x must always be greater than 0. And so that's going to govern our domain values. You can see it over here as well. When we started our domain values, we started at 0.1 and we made it larger. And so when we do our domain and our range values, we can say that our domain, which is all the x values, are elements of real numbers, and there's an additional restriction, and that is that x must be greater than 0. Now let's look at our range values from the graph. We're starting from negative all the way to positive. So our range values, which are our y values, range, which is y, is elements of real numbers, and it looks like all the numbers are possible all the way from negative infinity to positive infinity. Let's move on to the second feature now. Because our domain values had a restriction that x must be greater than 0, that means that the graph will have an asymptote, and the asymptote will be a vertical asymptote. It's going to restrict our x values, and so you have this time a vertical asymptote. And what is this asymptote? It is the line x is equal to 0, or the y-axis in this graph that we're looking at. So whatever values you choose, your graph will never actually equal to 0. Let's do an example. If you say that log base 2, and let's pick a very small number of 0.01, put this into your calculator, and you're going to find that it's equal to minus 6.643. And so as your x values are getting smaller, the y values that you get are large negative numbers. You will never get to 0, and so your graph is going to keep moving in this direction. The third feature for us to note is the intercept of the graph. So we're going to look at the x-intercept in these terms. And let's come back to our graph. Remember, the y-axis is an asymptote, and so your graph will never touch it. That is why you will not have a y-intercept, but you will have an x-intercept. And what is our x-intercept? When x was equal to 1, y was equal to 0. And that is our intercept. It's the point 1, 0. Let's move on and do one last graph. This graph is going to help us come up with the last feature of logarithmic functions that we need to understand. And the log function that we will do for this one is y is equal to log base 1 over 2 of x. All we've simply done is turn our base from being 2 to 1 over 2. Let's again define our domain and our range values. We'll use the same ones as last time. So our domain values are going to be x, 0.1, 0.2, 0.25, 0.5, 0.75, 1, 2, 3, 4, and 5. Let's again determine the range values that go with these domain values. You're encouraged to pause this video and calculate these for yourself so that you can do it in your tests and in your exams as well. I've pre-done it, and so I'm just going to fill in the values. I'll fast forward the video at this point. Let's draw this graph on the same Cartesian axis. We'll again start with the x-intercept, which we've defined, and that's the point 1, 0. So the x-intercept is staying the same. It's right over here. Yes. And let's move now to the decimal values. When x is 0.75, we found that y is 0.42. And when x was 0.5, it corresponded to 1. Let's draw these values. We'll start with the 0.5. When x was 0.5, you had 1. And when x was 0.75, you had 0.42. So somewhere about here. When x is 0.25, y is equal to 2. And when it's 0.2, we have 2.32. Okay, let's draw that value as well. When x is 0.25, y is equal to 2. When x is 0.25, y is equal to 2. And when x is 0.2, y is equal to 2.32. Let me draw these. When x is equal to 0.25, y is equal to 2. So somewhere about there. And when your x is equal to 0.2, y is 2.32. So somewhere about there. The last value that we will draw is when x is 0.1, your y is 3.32. When x is 0.1, your y is 3.32. So as you're getting smaller, going there. Let's move now to the whole numbers. When x is 2, y is negative 1. And when x is 3, y is negative 1.58. So when x is 2, y is negative 1. And when x is 3, y is negative 1.58. So somewhere about there. Let's do the last two. When x is equal to 4, y is negative 2. And when x is equal to 5, y is negative 2.32. When x is equal to 4, y is negative 2. And when it's 5, it's negative 2.32. So it's over here. Let's draw this graph again. The graph looks like this. And this is the graph of y is equal to log base 1 over 2 of x. Now let's look at what's happening with these graphs. When we had log base 2, when the values of our domain were getting bigger, the values of our range were also getting bigger, as we can see. But for this graph, when our values of the domain are small, our values of the range are large. And as the values of the domain increase, the values of the range decrease. And so this will be our last feature that we defined for logarithmic functions. Let's write it down to make sure that you understood it. We'll start by looking at the graph of y is equal to log base 2 of x. Remember, our base is defined as a, and so for a greater than 1, and that's what happens with this graph, your a is equal to 2, your base is 2, which is greater than 1. As x increases, these are your domain values, and as they increase, what happens is your y increases. And so the values of the range increase with the values of the domain when your base is larger than 1. Let's look at the second graph now. Our base was a fraction, 1 over 2. And so in this one, it's for 0 is greater than a, which is less than 1. This is going to give you a base that's a fraction. What happens is as x increases, so as the values of your domain increase, the values of your range decrease. And that is what we can see happening over here. As the values of our x increase, the values of our y become smaller. And these are all the features that we're going to look at for logarithmic functions. I hope you understood and were able to follow. If you have any questions, please leave them for me in the comments section and I'll try my best to answer all of them. Join us again in the next video. It will be the last video on Unit 3, and we're going to look at the relationship between logarithmic functions and exponential functions.